Hello students, the topic that we are discussing today is differentiation. It is a very important topic in calculus and it's a very important from your exam point of view. Now differentiation, what do you basically mean by the word differentiation? The basically meaning of the word differentiation is breaking into small fragments, right? Now, suppose there's a curve like this, any functional curve which we plot and we get a graph like this. This is a graph of fx. If I want to find out the slope of a tangent at point A, so differentiation provides us a method so that we can find the slope of a tangent at any point on the given plot of a function. Now I'm drawing a broader view of that point A. The function point looks like this. So this is point A which I have drawn. To find the slope at this point, I'm plotting these two values, right? See, these values are very small and they are denoted by del y, that means a small change in y, and del x, that means small change in x. Now, see, I'm drawing still the broader view of this. So it looks like this. This is my del y and this is my del x drawn at the point A. So if this angle is theta, we very well know that tan theta is given as del y by del x, right? Now, if del x is tending very small, that means if I write limit del x tending to 0, then del y by del x is represented as dy by dx. That means again the elemental change in y by elemental change in x. And we know that del y by del x is represented as tan theta. So dy by dx can also be represented in the form of tan theta, which is nothing but the slope of tangent on the given fx curve. Now, the next point is, as we saw here, that dy by dx is giving you the slope of the tangent at any point on the drawn curve, right? Now, suppose if the tangent is horizontal, that means the slope part is 0. So, that literally means that at that point, dy by dx equals to 0. So this is the significance of differentiation. What we do is just finding the slope of a curve at any given point which lies on the curve itself, right? So the first part that will deal with differentiation is called differentiation using the first principle. So differentiation using the first principle. So the formula for first principle differentiation is limit h tending to 0 f of x plus h minus fx whole divided by h. Now suppose if I have a function which is equals to x square and I want to find its derivative. So dy by dx equals to this formula from the first principle. So let's find out the derivative of the given function. If my fx is x square, so my f of x plus h will be x plus h whole square. So if I put it into this formula, so dy by dx should be equal to limit h tending to 0. Applying this formula, I get x plus h whole square minus x square whole divided by h. So that becomes x square minus plus 2hx plus h square minus x square whole divided by h. So x square gets cancelled, h can be taken common. So limit h tending to 0, if I take h common, I get 2x plus h whole divided by h. So I cancel out the h in the numerator and the denominator, and putting the value of h tending to 0, I get an answer as 2x. So differentiation of the given function x square equals to 2x. So this is the method, or this is the formula which we use once we are doing it by the first principle. The second part which we are going to learn in differentiation is very important and is called power rule. Power rule in differentiation is something which is the base of derivatives, and lot of sums are based on this particular formula. If y is equal to x to the power n, where n can be any natural number, any fraction, any decimal, anything, then dy by dx becomes n into x to the power n minus 1. This is the formula for the power rule which we use in differentiation. For an example, if I write y is equal to x squared, so the value of n here is 2. So if I now want to write the derivative of y, so I can write using the formula 2 into x to the power 2 minus 1, which is nothing but 2x. As we have seen from the first principle also, that the derivative of x square was 2x. So using the power rule, it becomes much more easy, and we can find the derivative of x square as 2x. Now suppose if the function is like this, y is equal to x to the power 5 by 2, a fraction. So the value of n is 5 by 2. So dy by dx becomes 5 by 2 x to the power 5 by 2 minus 1. So that is 5 by 2 x to the power 3 by 2, which can also be written as 5 by 2 x root x. That gives me my final answer. This is the way we use power rule in differentiation. Now we are going to discuss the other very important rule used in differentiation, that is called product rule. As you all know, product rule, product means multiplication. So product rule deals with the rule of differentiation if two functions are multiplicative. If y is represented as u into v, where u and v both are the functions of x, then the differentiation of this is given as u into differentiation of v plus v into differentiation of u. This particular formula is known as product rule in differentiation. I give you an example. Suppose if we are writing a function y is equal to x into e to the power x. So we take this as u and this as v. So applying the product rule dy by dx, we first write u as it is. So it is x into differentiation of e to the power x is e to the power x only, plus sign the v function as it is, and differentiation of x is 1. So we write 1. So my final answer becomes x e to the power x plus e to the power x. I can take e to the power x common and write my answer as this. This is how we use product rule in differentiation. Now product rule can be extended from more than two variables to three variables. In that case, the thing is, any of the number of variables remain constant and one variable get differentiated at a time. So this is how we use product rule in differentiation. The other very important rule in differentiation is called quotient rule. In quotient rule, as I as I told you that in product rule the two functions get multiplied. So in quotient rule the two functions are divided. That means if y is equal to u by v, where u and v both are the functions of x, then the derivative of such kind of functions is given as v into differentiation of u minus u into differentiation of v whole divided by p square. This is the formula which we use for quotient rule. Under quotient rule, we can have sums like this. If I give you y equals to x by x plus 1, here we need to apply quotient rule. That's because this is your u and this is your v function. Both are the functions of x. So if I'm writing the derivative of it, so the first thing is v, which is x plus 1, into differentiation of u, which is 1, minus u, which is x into differentiation of x plus 1, which is 1 again, whole divided by x plus 1 whole square. So my final answer becomes that dy by dx equals to, if I just multiply and open the brackets, it becomes x plus 1 minus x by x plus 1 whole square. So x gets cancelled. My final answer becomes 1 by x plus 1 whole square. Now this is the way we use quotient rule in differentiation. The other very important rule which is used in differentiation is called chain rule. Now under chain rule, as you can see, it is even called a smaller version of successive differentiation. So, under chain rule, if y is given as ax plus b to the power n, then my differentiation becomes n into ax plus b to the power n minus 1 multiplied with a. Basically, how does this rule works is, we assume that this whole function is x, which is in the bracket. So the differentiation of x to the power n is n x to the power n minus 1 using the power rule. Then we multiply the entire answer with the differentiation of the expression given in the bracket. So if I use the chain rule and I ask you to find the differentiation of 2x plus 1 whole cube, you don't need to expand the entire expression. You can use the chain rule directly and you can write your answer as dy by dx equals to 3 into 2x plus 1 to the power 3 minus 1 into differentiation of the thing given in the bracket. So the answer becomes 6 2x plus 1 whole square. This becomes an answer. So chain rule can be expanded to polynomials form, to the quadratic form. That means I want to say, if the sum is like this, y is equal to ax square plus bx plus c to the power n, which is a quadratic form. So my differentiation rule remains the same. It is n into ax square plus bx plus c to the power n minus 1 into again the differentiation of the thing given in the bracket, which is 2ax plus b. This gives me the form of differentiation of a quadratic expression raised to a power n using the chain rule. Now, the other very important part in differentiation is called stationary point. A stationary point is a point at which the slope of a curve equals to 0. What does that mean mathematically? Simply the point on the curve where dy by dx equals to 0. Now dy by dx is the slope of the curve at any point, as we have discussed earlier. So a stationary point is a point at which the slope of the curve reduces to 0. Now, there are other forms of differentiation also. Couple of the forms are known as exponent form. There are exponential differentiation. So the form of exponential differentiation is, if y is given as e to the power x, then the derivative of that with respect to x is also e to the power x. Now here the variations are, if y is given to you as e to the power mx, where m is any constant, then dy by dx, applying the chain rule, e to the power mx into derivative of mx, which is m. Similarly, chain rule with exponent differentiation can be expanded to the forms, if y is equal to e to the power ax plus b, then my differentiation becomes e to the power ax plus b into differentiation of ax plus b, which is b. So as students, you have seen that exponential differentiation can take these variations as well. So this will be the form which you'll be writing your answers in terms of derivatives. Now we go to some of the forms which is very important for trigonometric differentiation. Now for trigonometric differentiation, couple of formulas you need to learn, you need to memorize. The first one, it says, if y is equal to sine x, then the derivative of the function is equals to cos x, right? This is the formula which we use for trigonometric differentiation. Now, as you can see, we can discuss some of the variants over here. If y is equal to sine mx, then the derivative of the function becomes cos mx into differentiation of mx, which is m. Now, the third very important form, which is most commonly asked and student finds it a lot of difficulty in solving that. Suppose if it is sine to the power nx. In finding the derivative, we first use the power rule. So we write n sine to the power n minus 1x into differentiation of sine x, which is cos x. Please remember, this is a very vital form used combined power rule with trigonometric differentiation. Now, we'll discuss some of the forms for constant functions as well. Now, suppose if you have a function like this, y is equal to k, where k is any constant and does not contain x, and if we are differentiating the function with respect to x, the differentiation vanishes. dy by dx becomes 0. Please remember a couple of things. If it is an additive constant, then dy by dx, in this case, as the differentiation of x is 1 and k is 0, so the answer becomes 1 in this case. Now, if it's a multiplicative constant, k into x, then dy by dx becomes k as the differentiation of x is 1. So these are the couple of variations as a student you should keep in mind. If it's an additive constant, it becomes 0. But if it's a multiplicative constant, then it remains with the multiplication of the derivable function. Now, going ahead, I would like to discuss why the differentiation of a constant is 0. Suppose if I give you a function like this, y equals to 5. As I said, there's no x over here, so dy by dx equals to 0. Right? Now I'll tell you two ways why it becomes 0. The first thing, if I go by the power rule, so this is 5 into 1, and I know that the value of 1 is x to the power 0, right? Because any any value to the power 0 gives you the value 1. So if I'm differentiating that, so dy by dx, so 5 remains out. If I use the power rule, so that becomes 0. So I get 0 for a constant derivation. If I go by the graphical method, then y is equal to 5 is any line which is parallel to x-axis at all the junctures. Now, parallel to x-axis means if a tangent is drawn at any point on that line, that tangent will also be parallel to x-axis. As we have already discussed in the graphical method, that tangent, the slope of the tangent at any point is nothing but the derivative of the function. So we can see that any points plotted on this line y is equal to 5, the tangent will have a slope which is parallel to x-axis. So we can say that the derivative of any constant is 0 because of these two reasons. Now we'll be discussing a very important important kind of concept which is important from the exam point of view. It says that, please look at the question carefully, a cubic function, it says that a cubic function has y-intercept, has y-intercept 0 comma 2 when x equals to 1, y equals to 3, dy by dx equals to 2, and the second order derivative d2y dx2 equals to 0. You have to find the equation of the original curve. You have to find the equation of the original curve. Now this is the question. I repeat it. A cubic function has y-intercept 0, comma 2 when x equals to 1, y equals to 3, dy by dx equals to 2, and second order derivative. That means if I differentiate dy by dx again, I get the second order derivative equals to 0. find the equation of the original curve. Now these are the type of questions which are most commonly asked. So if I try to find a solution to this, the first thing which I'll be writing, if it's a cubical equation, so I can write any cubical equation in the form ax cube plus bx square plus cx plus d, right? This is my cubical equation where a, b, c and d are constants. A cubic, now y-intercept 0 comma 2 means the x value is 0 and the y value is 2. So if I put the x value as 0 and y value as 2 over here, so my equation becomes a into 0 plus b into 0 plus c into 0 plus d. So clearly the value of d which I found out is 2. So my new equation becomes y equals to ax cube plus bx square plus cx plus 2. Now this is the equation which I got, and I will be continuing with the same equation, right? So they have given us the value of x as 1 and y as 3 and dy by dx equals to 0. So continuing from the same equation, I write it again. We got y equals to ax cube plus bx square plus cx plus 2. The information given is x equals to 1, y equals to 3, dy by dx equals to 2, and second order derivative equals to 0. So I first differentiate this function. So I got dy by dx equals to, using the power rule, it is 3ax squared plus 2bx plus c, and the differentiation of a constant is 0. Now, as we know that the value of x is 1 and dy by dx is 2, so I put the value over here. So this becomes 3a plus 2b plus c. Now, this is my first equation which I got once we put the value of derivatives and x and y into the equation. Now, when x is 1, y is 3. That means if I put the value of y as 3 and x as 1 in the given equation, I'll get 3 equals to a plus b plus c plus 2. So my other equation becomes a plus b plus c equals to 1. This is the second equation which I got if I put the value of x and y into the original function. Now my third form is a second order derivative. So we know that dy by dx is this. If I differentiate that function again, I'll get the second order derivative. So if I'm differentiating this function again, what I'm getting is 6ax plus 2b. Now d2y dx2 is 0, so I place 0 over here and the value of x is 1 which is given to me. So that is 6a plus 2b. So the value of b which I get from this equation is clearly b equals to minus of 3a. A very important result which I got, and I can mark it as the third equation. So the three equations which I got after solving, I got b as minus 3a. Now, if I put b as minus 3a into this equation, so I will get a value b as minus 3a over here. So I'll get minus 3a plus c equals to 2. And if I put b as minus 3a over here, so I'll get minus 2a plus c equals to 1. I can solve these two equations simultaneously. So the value of c that I get is minus 1, and the value of a which I get will be c is minus 1. So the value of a which I am getting is also minus 1. Solving these two equations simultaneously. So you can see a and c is minus 1. So if a is minus 1 and I put the value over here, so I get b as 3. So the values which I got is a is minus 1, b as 3 and c is minus 1. So as we knew that my original equation which we got was y is equal to ax cube plus bx square plus cx plus 2. So if I put the values of a, b and c into the equation, as we got that the value of a was minus 1, so it becomes minus x cube. Since the value of b was 3, so it becomes 3x squared. Since the value of c was minus 1, so it becomes minus x plus 2. This is the equation of my original curve. This is what it was asked, and this is how we process any information given in the sum. Now, once we found out that equation, we need to check and verify whether the answer that we got is correct or not. So if I put x equals to 1 and y equals to 2, y equals to 3 into this equation, so I can see if x equals to 1 and y equals to 3, so I can write 3 equals to minus 1 plus 3 minus 1 plus 2, and I can see that this gets cancelled and LHS equals to RHS satisfies. So truly this lies on this curve, and this is how we solve any equation based on a stationary point, second order, and any cubical equation curve which we can get using differentiation. Thank you, students. Now start practicing differentiation.